Okay, guys, welcome. So today we're going to talk about second degree inequalities, right, or quadratic inequalities. Now, we spent a lot of time talking about how to solve quadratic equations, and it turns out that we're going to use a lot of the same methods to solve quadratic inequalities, right? So sort of the process here is you want to get everything on one side just like we did before, right? So you want 0 on one side and then everything else on the other side, right? And then, of course, what we're going to do is find when it equals 0, right? And we're going to sort of refer to those as critical values, right? Now, if you're on the left of that critical value, it's going to be positive or negative. And if you're on the right, it's going to be the opposite, right? As long as you have a linear factor, which is what we're going to hopefully do. All right, and then we're going to employ a table in order to sort of figure this out. And usually, instead of a table, I usually use a number line. I think it's a little easier. All right, so let me show you what I mean by that. So in part A, we want to solve x squared less than or equal to negative 3x plus 4. So the first thing I want to do is I want to move everything to one side. So we get x squared plus 3x minus 4 is less than or equal to 0. Well, now we can factor this. We can factor this into x plus 4, x minus 1. Right? And this would give me that x is negative 4 and x equals positive 1. Now, these two numbers are my critical values. Right? This is when it's equal to 0. So in between and beyond these things is when we're going to have positive or negative. So on a number line, let's mark off these values, negative 4 and positive 1. Now we can first talk about, do we even want negative 4 and positive 1 in our inequality? Now here, since we have equal to, we do want them, right? So since we have the equal sign, we're going to have an open circle here. All right, now what we're going to do is we're going to test a number in each region. Right, and what I mean by that is in this region of the number line, I'm less than negative 4. So for example, we could test negative 5. In this region on the number line, in between negative 4 and 1, so let's test 0. And in between, well, in this region, I'm bigger than 1, so let's test 2. Now what we're going to do is we're going to use the factored form, right? So we have x plus 4 and x minus 1, right? So for example, if x is negative 5, we're going to get a negative 1 times a negative 6, which is a positive 6. So when I tested negative 5, I got a positive number to come out, right? If I test 0, so this was for negative 5. If I test 0, I'm going to have a 4 times a negative 1, which is negative 4. So in this region, I'm negative. If I test 2, I'm going to have a 6 times a 1, which is 6, which of course is positive. So in this region, I'm positive. Now, if we look at our problem, we want this to be less than or equal to 0. So I want it to be negative. So I want this stuff. Right? So that's where my solution is. And of course, we could say this in interval notation by saying negative 4 to 1 with brackets on both. Right? And that's sort of the idea. Okay, let's look at part B. For part B, we have 2x squared greater than or equal to 5x plus 3. So if I move the 5x and the 3 over, I'm going to have 2x squared minus 5x minus 3 greater than or equal to 0. So now if we factor, I need to do 2 times negative 3, so that's negative 6. So we can use negative 6 and positive 1 to multiply to negative 6, but add to negative 5. So this is going to become 2x squared minus 6x plus 1x, which is plus x, minus 3. So now if we factor by grouping, in the first group I can take a 2x out, and I'll get an x minus 3. And then I can take a 1 out, and I get an x minus 3. Right? So then greater than 0, greater than or equal to 0, and now I'm going to have 2x plus 1 times x minus 3, greater than or equal to 0. And of course, this gives me x is equal to minus 1/2, and x is equal to 3. Okay? So those are my critical values again. So let's plot them on the number line. Now, of course, do we want these 2 points? Yes, we include the equal sign, so we want these 2 points again. All right, now let's pick a number to test in each region. So for here, I could use -1, for here, I could use 0, and for here, I could use 4. Now, again, we're using the factored form. We're using 2x plus 1 times x minus 3. Now, if I plug these in, note that we don't even really care what the number is. We just care if it's positive or negative. So I'm not even going to bother calculating the specific number. I'm just going to see if it's positive or negative. So if I plug in -1, I'm going to get a -2 plus 1, which is negative. And I'm going to get a -1 times a -3. Sorry, -1 minus 3, which is negative. So negative times negative is positive. So when I'm at -1, I'm positive. Right? If we plug in 0, we're going to get positive times negative, so negative. And if we plug in a 4, we're positive times positive, which is positive. So this part. Now, in this case, if you look at your sign, we do want it to be greater than or equal to 0, right? We want it to be positive. So we want these 2 regions. Right? And then, of course, in interval notation, you could say that this is -infinity to -1/2 with a bracket, and then union that with bracket 3 to positive infinity. So that's our solution for this one. Okay. Now, we can really apply the same principles to when we have sort of a rational expression here, right? So we have y plus 1, rational inequality, I should say, over 2y, 2 minus y, less than or equal to 0. So the nice thing about this is that it's really already sort of factored for you, right? So you're going to have critical values when y plus 1 is 0, because that's the top, so y equals -1. But you also have interesting things happen when 2 minus y is equal to 0, because then you have undefined. So that's another critical value. Now, the only way that this doesn't really, that this is a little bit different now, is that do you include these numbers? Well, -1 we include because that would make it 0, and 0 is okay. But of course we can't include 2 because that makes it undefined. All right, so we're not going to include 2. So now in each of our regions, we could use -2, 0, and 3. And if we plug these each into y plus 1 over 2 minus y, if I plug in a -2, I'm going to get a negative over a positive, which is negative. So this region is negative. If I plug in a 0, I'm going to get a positive over a positive, which is positive. And if I plug in a 3, I get a positive over a negative, which is negative. And since we want this to be negative, we want these 2 regions here. Right? And of course, in interval notation, -infinity to -1 with a bracket, since we want to include it, and we union that with 2, but don't include it, to infinity. Okay. Part B we can handle very similarly. We have a 2x minus 3 over a 1 minus 2x greater than or equal to 0. Right? So the top is 0 when x is 3 over 2, and the bottom is 0 when x is equal to 1/2. right? So those are my critical values. Now, the nice thing about this is that when you have fractions, that allows you to use whole numbers as your test values. All right, so now similar situation as before. Since I'm including the equal sign, 0 is okay, so 3/2 is fine, but undefined is still never okay, so that's still open circle. So now if we test some numbers, I can test 1, 0, and 2. All right, so again, we're using 2x minus 3 over 1 minus 2x. If I plug in a 0, I'm going to get a negative over a positive, so that's negative. If I plug in a 1, I'm going to get a negative over a negative, which is positive. Let me give myself a little more room. And if we plug in a 2, we're going to get a positive over a negative, which is negative. Right? And again, since we want this to be positive, this time we want the middle region. So then we're going to say we want a 1/2 to a 3/2, where we include the 3/2, but not the 1/2. Okay, so last two examples. Now we'll talk about how can we extend this to if there are more than 2 factors. Well, we just do it the same way we did before. So we have x minus 2, 2x plus 5, and 3 minus x. All right, so now this is actually third degree, because now if you distribute all this out, you're going to end up with an x cubed term. All right, but this will be 0 when x is 2. This will be 0 when x is negative 5/2. And this will be 0 when x is equal to 3. So now we just have 3 critical values here. Negative 5/2, 2, and 3. Now this time these are all getting open circles because I don't want to include it because I don't want it to be equal to 0. So now if we test the number in each region, I can test negative 3, I can test 0, I can test 2.5, and I can test 4. So now if we use this, for example, if I test negative 3, I'm going to get a negative times a negative times a positive, right? So that's going to give me positive. If we test 0, we're going to get a negative times a positive times a positive. So that's negative. If we use a 2.5, we're going to get a positive, positive, and a positive, which is positive. And if we use a 4, we're going to get positive, positive, and negative, which is negative. So now, of course, we want this to be negative, so I want this region and this region. So in interval notation, this would be negative 5/2 to 2, and union that with 3 to infinity. Okay, last example for this video. We have a 2y minus 9 times a 6 minus y times a y plus 5 greater than or equal to 0. Okay, so now this one will be 0 when y is 9/2. This will be 0 when y is equal to 6. And this will be 0 when y is negative 5. So now let's mark our critical values. So we have a negative 5, a 9/2, which is 4.5, and a 6. Now in this case, we want to include all of them because we have the equal sign. Okay, and now for some test numbers, we could use negative 6, we could use 0, we could use 5, and we could use 7. So now if we test negative 6, we're going to have a positive, and a negative. So overall, that's negative here. If I test a 0, I'm going to have a negative, positive, and a positive. So that's negative. Let's see, did I mess something up here? So it's negative 6. Yes, and this one, this should be Yeah, so if you can always tell that if this comes out not alternating, then you can always check and make sure that you did something right. And I think in that first term, I assumed I was doing 2 times 6, not 2 times negative 6. All right, so that should actually be negative, positive. Okay, now it looks good. Okay, so in this region, we're negative. So for 5, we're going to get a positive times a positive times a positive, so that's positive. And for a 7, we're going to get a positive times a negative times a positive, so that's negative. Now this one, we want it to be positive, so we want this region and this region. So then that's negative infinity to negative 5, and include it, and union that with 9 over 2 to 6, and include both of them. All right, so that's our solution for that one. Okay, so that concludes this video on second degree inequalities. I hope you enjoyed, and I will see you next time.